All right, today we're going to dive into the story of a real superstar inside our bodies, a true hero whose discovery, wow, over a century ago, just completely transformed medicine. It's working away inside all of us, every single second of the day. And we're not just going to look at it as a medicine, but as a fundamental character in the story of how we live and breathe and get our energy. I'm talking, of course, about insulin. So, to really get a handle on this, let's play out a little thought experiment. Imagine you've just had an amazing meal. Your blood is just swimming with sugar, which is pure, high-octane fuel. But what if your cells, the actual engines of your body, couldn't get to any of it? I mean, how wild is that? It's a total paradox, right? Your body is loaded with energy, but your cells are literally starving to death.
Well, that's exactly the crisis that insulin is here to solve. It's the body's master key. It's this amazing peptide hormone, and its job is maybe one of the most important in the entire body. It has to go up to each and every cell, find a special lock that it fits perfectly, and turn the key. And that simple action opens the door so all that sugar, all that glucose can finally rush inside and be used for energy. Without that key, all that amazing fuel just stays locked out.
Okay, so now that we know what it is, let's get properly introduced to this master key. Where's this thing even come from? And what's its mission, really?
Insulin's origin story starts right in the pancreas. See, deep inside are these incredible little workers called beta cells. You can think of the pancreas as this super smart command center. It's constantly sampling your blood, and the second it detects that glucose levels are climbing, like right after you eat that meal, it immediately sends out insulin into the bloodstream to get the job done.
And its job is way bigger than just dealing with sugar. Of course, rule number one is keeping blood glucose in that perfect sweet spot, that healthy range. But it does so much more. By getting that glucose into the cells, it fuels literally everything we do. It also acts like a security guard, telling the body, hey, we've got plenty of fuel, no need to break down our own fats and proteins. And all of this together supports our growth, our metabolism, the whole shebang. It's a serious multitasker. Okay, so we keep calling it a key, right? But how does it actually work? How does it turn the lock? Let's zoom way in and look at the actual elegant mechanism that insulin uses to power up our cells. It's a pretty elegant three-step process, actually. First up, the insulin key floats around until it finds its perfect match, the lock, which is an insulin receptor right on the outside of a cell. When it clicks in, it sends a signal, like a doorbell ringing, deep inside the cell. That signal tells these special doorways, called glucose transporters, to come up to the surface. And boom, those transporters open up and glucose can finally flow from the blood right into the cell. And just like that, fuel delivered.
And the result of this whole perfectly choreographed dance? It's this beautiful state of balance. The technical term is glucose homeostasis. And all it means is there's not too much sugar in the blood and there's not too little. Everything is just right. And that allows our body to work at its absolute best. That right there is insulin's whole mission.
But what happens when this amazing system breaks down? What if the body just stops making the key? Or what if the locks on the cells get all rusty and don't work anymore? Well, that's when the body has to call for backup. And that backup comes in the form of insulin therapy.
And this really breaks down the two main scenarios where that backup is needed. On one hand, you have type 1 diabetes. In this case, the body's own immune system has destroyed the beta cells, the little factories that make insulin, so there are no keys being made, period. For people with type 1, insulin therapy isn't just a treatment, it is quite literally a lifeline. Then you have type 2 diabetes. Here, the body is still making insulin, but either it's not making enough or the cells have just stopped listening to it. The locks are faulty. In this case, insulin therapy might become necessary when diet, exercise, and other medications just aren't enough to keep things in balance.
And hey, it's not just about type 1 and type 2. The body might need to call in those reinforcements in a few other situations too, like during pregnancy with something called gestational diabetes, or in a serious medical emergency like diabetic ketoacidosis, or DKA, where blood sugar gets dangerously high, or even when the body is just under massive stress from a severe illness or a big surgery. In all these moments, extra insulin can step in as absolutely critical support.
Now, because all these situations are so different, you can't just have a one-size-fits-all solution, right? Of course not. And that brings us to what we have today, the modern insulin toolkit. It's this whole sophisticated set of different insulins, each one engineered to mimic the body's own natural patterns and to meet very, very specific needs.
This chart kind of gives you a peek into that toolkit. So you've got your rapid-acting stuff. Think of it as the sprinter. It gets to work in like 10 to 15 minutes, perfect for covering the sugar from a meal. Then you have short, intermediate, and long-acting types. Each one is designed with a totally different speed and a different duration, all to cover the body's needs, whether it's between meals or all through the night.
Okay, I want you to focus on this one phrase right here, minimal or no peak. This is talking about long-acting insulin, and I'm telling you, this was an absolute game changer. See, before this existed, trying to manage blood sugar between meals and especially overnight was this constant roller coaster. This stuff provides a slow, steady background trickle of insulin that lasts for 24 hours, sometimes more. It's like having this perfectly flat, reliable foundation that mimics what the body does naturally, and it's so critical for preventing dangerous highs and lows.
And then, to make things even more straightforward for some people, you've got a combo tool. Premixed insulins. They basically bundle a fast-acting type for meals with a longer-acting one for the background. This way, you can cover both of your bases with just a single injection. It's really all about making this life-saving therapy as, manageable as it can be.
All right, so let's wrap this up. What are the big things you need to remember? First, insulin is that master key that lets sugar into our cells for energy. Simple as that. Second, it's made by our pancreas with one goal: keep our body in perfect balance. Third, when that natural system isn't working right, insulin therapy becomes an absolute lifeline. And finally, that therapy isn't one thing. It's a whole toolkit with different tools designed to mimic the body's natural rhythms.
Insulin's first century was absolutely revolutionary. It's become a cornerstone of medicine and saved millions and millions of lives. But that story, it's nowhere near finished. Which brings us to a final thought. What innovations are going to shape insulin's next chapter? Are we talking about smarter insulins, new technologies, groundbreaking discoveries? Really makes you wonder, doesn't it?